Hi, everybody. Welcome to Build. I hope you guys are having a great time. Hope you guys picked up your hardware and are enjoying it. Welcome to my talk, Unlocking the Power of DirectX in Apps that Use XAML. So this is a 400 level talk. I'm assuming a little bit of knowledge about DirectX and XAML. Can I get a show of hands? Who's built a DirectX app before? Okay, so quite a bit of knowledge there. Who's used DirectX and XAML interop to build apps before? Okay, a few less people, so hopefully this is great. This is exactly my target audience. Since I'm assuming a bunch of knowledge already, I might skip over a few things, especially XAML-specific, lower-level XAML concepts, and some DirectX ones as well. So if there is something you don't understand, please feel free to stop me and ask questions as I go along. So first up, a little bit about me. I am a senior development lead on the XAML team. In the Windows 8.1 release, I worked on the graphics, media, and text stacks in the XAML platform. Previously, in Windows 8, I worked on the XAML graphics stack exclusively. You may know that a lot of what's now the XAML stack in Windows evolved from Silverlight. And though we took a lot of Silverlight code, we didn't take most of the graphics code when we moved across to Windows. We have a fully accelerated stack in Windows 8 and 8.1 for XAML. And through the Windows 8 release, I worked primarily on building that. Before that, I did work on the Silverlight team. Before that, the Windows Presentation Foundation team, the Desktop Window Manager. So spent my time at Microsoft working on display technologies, UI, things like that. Outside of work, you might notice from my fairly slight accent now, I'm not from here, I'm from Australia. I left it behind 8 years ago and I've been living in Washington State since then. So I've traded in these guys, which are, everyone seems to be fascinated by how dangerous it is to live in Australia, but don't actually encounter these on a regular basis. And now I do this. That's me down in a crevasse up in Mount Rainier in Washington State. I didn't actually fall down into the crevasse. I got lowered down there so that I could practice climbing out, because that's what I like to do on the weekends. This is what I think is a good time. Take that for what it's worth. Anyway, XAML and DirectX interop. There are three main things I'm going to talk about today. Firstly is why. Why do you want to use DirectX in your XAML application? What is the value that this is providing to you and to your application users? Secondly, once I convince you that this is a really valuable proposition, I'm going to explain to you how you can integrate DirectX into your XAML application. There's two main different API sets that we use. There's 4 APIs I'm going to talk about, but they are divided into 2 main different categories. And I will explain to you what each of those is for, what kind of application scenarios they're useful for, and how to actually use them. Thirdly, independent input is a new feature we've added in Windows 8.1 to some of our DirectX interop APIs. And I'm going to explain to you what the value of independent input is, what independent input is, and how you can use it together with XAML and DirectX interop in your applications to create great, fast, fluid, performant experiences. So first up, why use DirectX in your XAML application? So XAML is actually the first Windows UI platform that includes fully integrated and high-performance DirectX interop. We did have some DirectX interop in WPF through D3D Image, for those of you that have used that. But in XAML, we've been able to go much further. That's basically through our integration with the rest of the system. XAML is built on direct composition, and using that API set, we've been able to build really tightly integrated DirectX interop into the platform. So one of the reasons XAML and DirectX interop is a great idea is because now you actually can do it really well. So first up, what is XAML for? So XAML is all about building UI. So it's focused on building great UI experiences and has a very rich set of controls, primitives, all very easily accessible. Rectangle, text block, shapes, list view, grid view, flip view, scroll viewer, all of these fantastic high-level APIs, and they're all very easily accessible. You can create them via code, you can create them via markup, you can access them from code behind. There's a rich property system. It allows animations, data binding. Accessibility is included, localization, all of these things are included in the UI framework. 6 lines, 8 lines of XAML right there to get some images and a button on screen. So pretty straightforward. And it's really great for developer productivity. So you can get a lot of stuff, a lot of pixels on the screen with a very small amount of code using XAML. Pixels on the screen is what I'm all about, so I'm a big fan of this. What's DirectX for? So DirectX is a much lower level set of APIs that are in the Windows framework. They're very flexible, scalable, and highly performant. If you want to get a pixel on the screen, everything eventually does go through DirectX in Windows. It's very customizable. You can use pixel shaders, vertex shaders. You can draw your own meshes. You can have a geometry shader. Any kind of custom effect that you would like to apply, you can do it during DirectX. It goes all the way to the middle. It's basically the closest thing between you and the driver. Direct3D is the lowest set of graphics DirectX APIs. So pixel shaders, vertex shaders, etc. As I mentioned, Direct2D is a 2D API set primarily built on top of Direct3D, and that makes it easier to get some 2D API on the screen. If you've ever tried to draw a rectangle, just a flat rectangle using Direct3D, there's quite a lot of code. Using Direct2D, it gets a lot quicker. Windows imaging component, this is for decoding and displaying images, so using that in conjunction with Direct3D and Direct2D is what we do in XAML and what you can do when you're writing your own DirectX apps. DirectWrite is the Windows text stack, does text layout, text formatting, text rendering, font system, etc. Direct composition is the system compositor, and it basically combines UI and allows for smooth animations. Direct manipulation is the system that allows for independent input for scrolling and zooming scenarios. We in the XAML team think DirectX is fantastic. That's why we built all of XAML on top of DirectX. We actually undertook a major effort in 8.1 to integrate more deeply with the DirectX stack by moving our XAML compositor out of process into direct composition. So we are now tightly integrated with direct composition, and I'll explain some of the benefits of that later on. This is a great example of something you can do in Direct3D that you can't do in XAML. So nice 3D scene there. So DirectX and XAML together basically provides you the best of both worlds. If you're building your UI and controls, you can use XAML. Custom graphics, image editing, games, etc., you can # DirectX. The architecture diagram here, which you're probably pretty familiar with at this point, you can build your Windows Store app using XAML, C++, C#, or VB, and that can talk through the Windows runtime layer to the XAML framework, where we run all of our code, windows.ui.xaml.dll. That's actually layered on top of the rest of the Windows 8, what we call the Windows 8 subsystem, and that is that's a great way to write apps. What we've added with XAML and DirectX interop is the ability to go directly from your store app into the DirectX API set while still using XAML. So you don't have to switch wholesale to DirectX. You can use both together. One caveat, the DirectX APIs are not WinRT projected, so the types are not IInspectable derived, meaning you do have to use IUnknown and you have to write in C++. So the important thing to note, though, is that your DirectX component has to be written in C++. The rest of your application can still be written in whichever language you choose. So many great applications you already use are built with DirectX interop in XAML, even if you weren't already aware of it. These applications in the Windows Store are built with DirectX interop. OneNote, FreshPaint, the Bing Maps app, the PDF Reader, many games, especially a lot of the games written by Microsoft Game Studios. So to give you some visual context for what I'm talking about, the OneNote document canvas here is all built using DirectX. So they have a very custom layout requirements, and they want their layout to look the same on all different devices that OneNote supports. So they render into a DirectX surface using Direct2D, and then we can integrate that into XAML, and the rest of the Chrome and the scroll viewer, the panning indicator on the right, are all XAML content. FreshPaint, fantastic app. This is a really heavy user of DirectX. They actually use basically all of our DirectX APIs in XAML somewhere. Custom artwork by yours truly there. And the app bars at the top and bottom are actually the XAML in this case. These guys, we worked closely with these guys during Win8 development, and they were fantastic to work with. We They found lots of bugs for us before we shipped, and we found out what great experiences app developers would be able to build with XAML and DirectX interop. These were basically our first really heavy user of XAML and DirectX interop before we even shipped. Bing Maps, another very close partner of ours, the mapping surface is all DirectX, and so they can draw all 3D and have all their custom vector drawing. And once again, the app bar is written in XAML, and if you've used the directions pane, and the directions are also XAML in this application. Games, this is a game called Adera from Microsoft Game Studios, and similar to Bing Maps, there's a DirectX surface in the background there where they're drawing with their 3D scene, and the app bar at the top is actually XAML. The menu system in this game is also composed of XAML. So hopefully now I've convinced you of the value of DirectX and XAML interop. If you weren't convinced already, you are already here, so hopefully I've gotten you over the line. So now I'm going to get into the actual nitty-gritty of how do you get this done? What do you need to do to build DirectX interop and XAML? So there are two main different API sets for building XAML and DirectX interop. The first is if you want to consider a DirectX surface in a XAML application as a brush, so like image brush, radial gradient brush, linear gradient brush, these are all used to fill XAML shapes. You can use surface image source or virtual surface image source, which are image source derived classes, and that'll get you really tight integration into the XAML framework. If you want to have tight integration into the system compositor and low latency presentation, you want to control all of your own timing, and you want to create, if you want to have very tight interactivity, swap chain panel and swap chain background panel are the way to go. So first up, surface image source and virtual surface image source. So surface image source, this one, as I said, derives from the XAML image source type. Think of it as a dynamically updatable D2D or D3D bitmap. So just like bitmap image, but you can fill it with DirectX content, and then you can use that surface to fill any XAML element. So pretty simple example right there. You have an image brush, you set the image source to surface image source, and then you can use that image brush to fill just a regular XAML primitive. There's a fairly simple application, a fairly simple model for you to update the content in your DX surface. So the application creates their own D3D device or D2D device. XAML will provide a surface to draw to update the surface, and the XAML framework, once you're finished drawing that surface, will actually retain those updates in the tree. So you don't need to keep redrawing the content. The XAML framework can just keep it and manipulate it. We can animate it around, and you only need to update it when you actually have new content to display there. So how does this actually work? So we have an interface called iSurface Image Source Native. This interface is actually IONknown, so it's not IONspectable. The reason for that is that these types are, the DirectX types are not WinRT exposed, so they can't be derived from IONspectable. So we end up with this IONknown derived type, and there's a little bit of magic to get access to this interface, which I'll show you a little bit later in Visual Studio. It's also in all the samples, so don't worry if you don't remember it. But once you have access to this interface, fairly straightforward. There's a set device call. This is how the application can provide their DXGI device to the framework. When they want to initiate an update to draw to the surface, you can go ahead and call begin draw, pass in a rect that you'd like to update, and the framework will pass back a DXGI surface to form those updates on, so to render D2D and D3D content into, and an offset in that surface to do that drawing at. So we may actually pass back a larger surface than you request to enable some performance enhancements, so we can reuse surfaces and not be reallocating them in video memory, because that tends to be pretty expensive. Once the app's done drawing, they can call endDraw to commit those updates. These methods have to be called from the XAML UI thread, so just like every other dependency object, or most other dependency object derived APIs, they're UI thread bound. So summing up, how do you use surface image source? Go ahead and create one. Create or use your application D3D device and set it on the surface image source. Set the surface image source on a XAML elements image brush. This is how you connect it to the XAML element tree. Once you've done that, to actually get D3D or D2D content into the surface, you can call begin draw, and then on the return surface, draw with D2D or D3D. Once that's complete, call ndraw, and the XAML framework will pick up those updates and get it on screen for you. So, demo time. I'd really like to be able to write a bunch of this code for you on screen, on stage, but unfortunately the DirectX code is pretty verbose, so I'm going to go with an application that I prepared earlier. So this looks like a regular XAML application, but the Chrome here on the left this is all XAML content. This image in the right is not actually a XAML image. This is an image loaded using Windows imaging component and then drawn with Direct2D into a Surface image source. It's some fairly static content. We don't need to update very frequently, but to show you that this is actually something interesting other than just using an image, I can apply some effects to it. So this is using the D2D imaging effect APIs, and every time that I change one of these parameters, I just redraw the Direct2D content with some new parameters and some new filtering. And I only actually need to do that whenever I make a modification. So I don't have DirectX code running in the background continually updating this surface. I just do it once, and then the XAML framework can keep recomposing it after that. So I mentioned I would show you some of the interesting things in this project. In this example, I have two projects. I have the scenario 1 component. This is actually the C++ project containing the DirectX code. And I have the surface image source actual application, and this is written in C#. So as I said, you can actually, even though you have to use C++ to write your DirectX code, you can still use C# for the rest of your application logic, which makes this really powerful and enables you to get the best productivity you can. A little bit of interesting code to get access to the iSurface image source native API is here. First derive an iSurface image source native object, and then you take the surface image source derived type. This class is derived from surface image source. You need to reinterpret cast that to IUnknown, and then call query interface with the IID of the iSurface image source native type. Unfortunately, because it's not IInspectable derive, you do have to do this reinterpret cast. If you don't do that, then the QI will fail for this API. Fortunately, this is pretty simple boilerplate code. All the samples have this, the surface image source sample on MSDN and the various other DX XAML interrupt surfaces, samples. So don't need to worry about keeping or copying this. You can just do that once to get access to the API, or you can do it every time you need it. It's not a big deal. This sample does it each time it needs to call the API set. Okay. So next up, virtual surface image source. So this is a type that derives from surface image source. And basically, it's for very large surfaces that are too large to fit in video memory. Some of you who've worked with DirectX before are probably familiar with the concept of max texture size, which is a limitation that each device has, each hardware device, that you can only create a texture that's a certain size in pixels. So in order to work around, this is a kind of a blocker for doing good UI framework development. So in order to work around this, we provide some virtualization for you. You can create a conceptually very large virtual surface image source. You can create one that's 1 million pixels by 1 million pixels. And the XAML framework will do virtualization for this based on tiles. So we'll divide the surface up into tiles, and we will figure out which tiles are on screen or about to come onto screen, and notify the application that it needs to draw those tiles. So you can see a great mapping example there. That's a great scenario for for using this API. It's also useful for large document canvases. So the OneNote example that I showed before actually uses this API. They just create a really large surface and then draw the contents that are on screen. And that way you're able to just pan through the virtual surface image source to pan your document and add content as anywhere in the large canvas that OneNote supports. The XAML framework will automatically manage the tile cache, so we will discard old tiles to ensure that you're not using too much video memory. You don't need to worry about trimming or flushing, anything like that. So once again, this is another IUnknown derived interface. It in fact derives from iSurface image source native. And there's a callback interface that you as an application developer need to implement to allow the XAML framework to call back to you and say, hey, we need you to update some content. Once you've implemented that, you can register that implementation object with the vsys. And when you do get the callback, you can go and ask the framework, okay, which are the recs that I need to draw? We also support an invalidate API, so if there's some content off screen that you think the framework has you've already generated but is no longer visible, you can, and you would like to update it, but you don't want to do the rendering now because it's not actually on screen, you can call invalidate, and the XAML framework will mark that area as dirty, basically. And then we will discard those resources, and when they're going to come into view again, we will call you back and ask you to draw them, just as we would if you'd never provided content for that area. So, really quick walkthrough how to implement the virtual surface image source callback native interface. It's a bit of a mouthful. Call register for updates needed on the vsys. In the updates needed callback, call get update rec count and get update recs, and then go ahead and render those rectangles using Direct2D, Direct3D, using the same begin draw, draw, end draw pattern that's used for the surface image source. So fairly straightforward. So everything I've talked about so far was in Windows 8. We have added some features to these APIs for Windows 8.1. Primarily, they're focused on faster Direct2D drawing, especially to multiple surface image source surfaces, and multi-threaded drawing for surface image source and virtual surface image source. So faster Direct2D drawing. With the Direct2D API set, there is a amount of CPU work that goes on. They batch up a lot of the implementation down to D3D. And with the Windows 8 model, if you wanted to draw to a number of different surface image source objects, then we would have to flush each of those Direct2D batches of work after each individual surface was drawn. So this works reasonably well, but it could be more efficient. So what we've enabled through device batching is the ability for you to get back a D2D device context when you draw your surface image source instead of an IDXGI surface. And that allows the framework to batch up a large amount of the Direct2D work and just flush it all in one batch. So overall CPU utilization will be smaller in this scenario if using D2D device context batching. This is really useful for things like thumbnail generation if you're drawing custom thumbnails. Anytime you want to draw a large number of surface image source objects. So based on scenario, this can be more convenient. So another IUnknown derived interface. You guys must be getting really excited about these now. iSurface image source native with D2D. It's a pretty straightforward name. It has a similar pattern to the previous interface. There's a set device call, but this one actually takes an IUnknown rather than IDXGI device. And that device needs to either be the IDXGI device or an ID2D device if you would like to use D2D. Once you've provided that, there's a similar begin draw API. Passing the update rect, the object is the same, but you also have to pass in an IID stating whether you would like an IDXGI surface back or an ID2D1 device context back to draw with. End draw, still the same. We've also added a couple of other APIs to allow for suspending and resuming drawing to a surface image source. One of the restrictions of the surface image source and virtual surface image source APIs is that you can only have one outstanding begin draw in the system at a time. You can't be drawing to multiple surfaces simultaneously. So the suspend draw and resume draw APIs allow you to say that, okay, I'm not done drawing to this surface, but I want to start drawing to another surface for a while. So you can suspend drawing on one surface and then call begin draw on a different surface, end draw the new surface when you're done with it, and then come back, resume draw, and keep drawing on the first surface. This is a fairly niche implementation, but it's one of those features that if you need it, you really need it. But for a lot of people, it's probably not going to be something that you would use. So the second major improvement we've made for surface image source and virtual surface image source is multi-threaded drawing. As I pointed out before, most of these APIs up until now have been restricted to the UI thread. And the issue with that is that Direct2D and Direct3D rendering can be expensive in CPU terms, depending how complex the scene or your content that you're drawing is. So the problem there is that you can start bogging down your UI thread, and the UI thread needs to be responsive to keep input flowing and the app user having a good experience. So we actually had one of our customers in Windows 8 go ahead and implement multi-threaded drawing even without any support from us. The PDF reader team would call begin draw on the UI thread, and they would take the surface that we provided them, and then they would marshal that to a background thread. They would do their direct 2D rendering there, and when they were done, they would marshal back to the UI thread and call ndraw, and that worked very well for them actually, but we wanted to make this easier for application developers to not have to do so much cross-thread marshalling. So we enable this on the same interface. There's actually no new APIs for this, but the iSurface image source native with D2D has the begin draw, suspend draw, and resume draw APIs can be called from any thread, not just the UI thread. The ndraw API still needs to be called from the UI thread, and the reason for that is that we need a way to synchronize the content updates in XAML, so that if you wanted to update a number of surface image sources with the content from the rest of the XAML tree, you can still do that by calling ndraw and making those updates in the same UI thread callback block. The reason the suspend draw and resume draw APIs are really useful here is that if you want to draw a bunch of Direct2D or Direct3D content off thread, you can call begin draw on one surface, draw it, then call suspend draw, and then switch to a different surface, call begin draw, suspend draw, and you can take all of those surfaces that are now suspended and ndraw them all at once on the UI thread to commit those updates all together. So that's the surface image source, virtual surface image source API set. The next set of interop options in XAML are all based around swap chains. In Windows 8, we had swap chain background panel, and in Windows 8.1, we've introduced swap chain panel, which I'll talk about shortly. So FreshPaint, once again, my favorite example. The swap chain background panel is what those guys use to get the fluid inking experience they have in that application. This is an API that allows you to use DirectX content, the swap chain, as the background for a XAML app. So it allows low latency presentation, as I said, and you can also do the rendering and presenting of your swap chain on a background thread. So you can do this all independent of the XAML UI thread once you've associated the swap chain with the XAML tree. It's designed for a specific set of scenarios. So it does have to be the DirectX content has to be the background element, and it must be full window sized. So even if you create a swap chain that's smaller than the full size of the window, the XAML framework will scale it up so that it fills the whole background. This is a little bit restrictive. So for Windows 8.1, we added a swap chain panel, which is pretty similar to swap chain background panel, but with a few less restrictions. So the Z-order limitations have been removed, and that means that you can layer the swap chain panel anywhere in the XAML scene. It's composable like any other XAML element. Any size swap chain can be used. You can have more than one swap chain. I wouldn't say you can have as many swap chains as you like because they're fairly expensive objects to have around, but previously you could only have one, and now you can certainly have 3 or 4. We also provide a size change notification, and this will be fired anytime the swap chain panel is actually resized. Now that it's not the full window background size, the swap chain panel can get resized like any other XAML element. Imagine it's hosted in a scroll viewer and you do a pinch zoom. Then the swap chain panel will get zoomed up, and unfortunately that means the pixels in your swap chain panel will get blurry. So we give you a size change notification to allow you to know when you need to resize your swap chain and draw at a higher resolution. The other thing I wanted to point out was the same work that allowed us to do this was the work that enabled the web view improvements in Windows 8.1. I don't know if you guys have ever used a web view in XAML, but you probably noticed that it was always layered on top. So the web view was always on top, and the swap chain was always at the back. These were the limitations we had in Windows 8. Since we integrated XAML with the direct composition engine in Windows 8.1, we were able to solve both of these issues to have fully composable UI without having those airspace problems. So how does this API work? Once again, IONknown derived interface, and this one's much simpler. You call set swap chain to associate your swap chain with the XAML element, and once you've done that, you can render and present that swap chain on another thread you need to call this API on the UI thread, but actually controlling the swap chain you can do from anywhere. Likewise, for swap chain panel native, the same API exactly. So it's pretty simple. OK, so swap chain panel demo. Once again, this would take a little too long to write here in the room, and I don't want you guys to fall asleep on me. So here's another application that I built earlier. Once again, it's the same kind of pattern with a C++ project and a C# project. And I'm waiting for the C++ to build there. Application logic mostly in C#. There's a fairly limited amount of application logic in this one. I'll show you the main page of XAML right after this. So this is a swap chain panel, and this is the direct 3D sample you guys might have seen before, just a spinning cube. It's pretty simple. The great thing here, now that there's a swap chain panel rather than a swap chain background panel, is that I can just move this around. So I have XAML pointer events hooked up to this to move this. And there's also XAML UI underneath it, text, swap chain panel demo, and there's XAML buttons on top of it. I can even apply XAML animations to the swap chain panel, opacity, and I can control the actual rendering of the D3D surface as well. So super exciting. Really like this feature. OK, so now that I have talked about the two API sets, I want to explain a little bit about which API you should use when. This is something people have a little trouble with sometimes because it's pretty subtle which API set should be used for which scenario. So surface image source and virtual surface image source are when you want to integrate your content really tightly with the XAML tree. I give the scroll viewer example because that's how the virtual surface image source is really tightly integrated to the system. If you put your VSys inside a rectangle and put that in a scroll viewer, then you can pan around the VSys very easily and with independent manipulation. And we'll give you the callback saying here's when the next content you should draw. The important thing to remember is that surface image source and virtual surface image source are designed for discrete content updates. So you think about the OneNote example. They have a large document with custom rendering, but they're not doing continuous updates. They're not doing animations and trying to hit 60 frames per second inside that DX content. The XAML framework can manipulate the surface at 60 FPS successfully using independent animations or direct manipulation, but they're not trying to push content through into the surface at 60 FPS. This is a little analogous to DirectX if you're thinking about the rendering pipeline there. Sys and VSys are like textures, and the swap chain panel and swap chain background panel APIs are swap chains. So if you want to do really fast updates in a continuous way, swap chain panel and swap chain background panel are the way to go, because when you do render and present on those update operations go directly through to direct composition. They don't go through the XAML UI thread, so they're the best way to get lowest latency updates that you can have. The Sys and VSys API updates will be limited to the maximum frequency by the XAML UI thread, which is not guaranteed to run at 60 frames per second, depending on what application logic is being run there. So third, last but not least, is independent input. This is a feature that we've added to swap chain panel and actually swap chain background panel, and allows you to get the ability to get touch, pen, and mouse input on a background thread rather than the XAML UI thread. So this provides a path for high-performance, low-latency interactivity. So talking a little bit about the different kinds of input, dependent input is the kind of input we call that arrives on the XAML UI thread. So most of the pointer events that you would subscribe to on a XAML element will come up on the XAML UI thread. So pointer pressed, pointer moved, pointer released will all have been on the XAML UI thread in Windows 8. This means that those events can compete with other work that's happening on the XAML UI thread. It's a pretty busy place to be. All kinds of application events get fired there. Application code runs, framework code runs for layout and rendering, and that means that if the input messages that you're receiving are discrete, so they're making discrete updates, like if you tap a button or toggle a toggle button then those are the kind of input updates that are very well handled on the UI thread. If you want to do something that requires some continuous updates, like if you want to drag your rectangle across the screen and have it track your finger really well, if you hook up to pointer moved and pointer pressed for that, then you'll find that if the XAML UI thread gets really busy, the continuous motion of that element will be affected. In the framework, we allow you to do independent manipulation by using a scroll viewer. So if you put that element in a scroll viewer and just scroll it around, the application will feel pretty smooth. And the way we do that is by having off-thread events in the system compositor picking up the updates that are coming direct from the touch engine. So we call that independent input, and that's enabled by direct manipulation. What we've done with independent input on swap chain panel is give the same flexibility to developers to use independent input on another thread for scenarios that extend past just panning and zooming. So with independent input and independent output via swap chains, you can have a fully independent cycle on a background thread that provides a really fast, fluid experience. So in diagram form, imagine an application here with some XAML, a swap chain panel, and some more XAML on top of it. In Windows 8, all of the input processing happened on the UI thread. And even if you're doing your rendering on a background thread, if some of that rendering depended on UI thread input, then that would have to be marshaled cross-thread, and that rendering could only ever happen at the frequency that the UI thread was running at. With independent input, my clicker's not working. Oh, there we go. OK. What we've done is broken out the input that's going to that DirectX panel and allowed you to receive it on a different thread. So how do we do this? This is actually a WinRT type, the first I've shown, so that's fantastic. There's an API on swap chain panel called create core independent input source, and what you need to pass into this is an enum which describes which types of input you would like, so mouse, pointer, and mouse, touch, and pen. I always get these confused. You can choose just one or two or all three to be redirected to this object on the background thread. When you call this API, we'll pass you back a core independent input source. And what that type has on it is a bunch of events, properties that are all related to input processing. So you recognize some of these are very similar to the XAML UI thread pointer events: pointer press, pointer release, pointer moved, pointer position, etc. So how do I use this one? The first thing you do is create a swap chain panel and attach it to the XAML tree. You can then create an IDXGI swap chain and call set swap chain on it to set the swap chain on the swap chain panel. That once again happens on the UI thread. Number three, is create core independent input source. And you need to call that on the background thread from which you wish to receive the input. So you need to call that on the thread that you're going to receive the input, not on the UI thread, so that it knows where to send the input. Once you've done that, created a background thread and created that object, you can set it up to process that input using the dispatcher and render, process input, render, and present in a loop, and profit. Good times. So let me show you a demo of this. Once again, a lot of code to write in the session here, so I prepared these a little earlier. This is an inking sample, and I actually did this deliberately on the X220 laptop I have because it has pressure-sensitive ink. So this is an example of running input on the UI thread for inking. The center box here is a swap chain panel, and I have some XAML UI Chrome at the bottom here. So I can draw some ink. This is just drawing direct 2D strokes between the last point and the current point with some adjustments for thickness based on the pressure sensitivity of the pen. And I can even use the eraser, which is pretty cool. This works actually reasonably well on this very fast machine on the UI thread. So you might wonder, what is the point of independent input? If I add in some simulated UI thread interference here, this is just running a little bit of math every 100 milliseconds or so on the XAML UI thread on an async callback, then my input starts to degrade pretty rapidly. You can see now, if I try to draw myself a little friend here, Not sure if you'll even be able to recognize this. Maybe the number of legs will give it away, but for nostalgia's sake, you can see my ink's not looking great here. So this is on my plugged-in, powerful X220 laptop. You can imagine on a Surface, you can end up with performance problems even more quickly and even without simulated interference here. So I have another project here which I've converted to use the independent input. Let me go ahead and stop this project first. This may look very similar because it is actually the same, but you can see now if I turn on some interference, and I can still draw really smooth ink despite what's going on in the UI thread. My spider may not look much better because some of you guys might have very small children who are better artists than I am, but hopefully I'll get the point across there. Okay. So, summing up, you can use XAML and DirectX together to create some great apps and games. You can use swap chain and Surface-style interrupt depending on the scenario, and I want to reiterate that be careful when you consider which API to use. The performance characteristics of each are tuned for a particular scenario, so the swap chains are designed for low latency interactivity, and the Surface image source and virtual Surface image source APIs are designed for you to tightly integrate with the XAML tree for custom drawn content that doesn't necessarily update at 60 frames per second. The addition of independent input also allows you to do custom rendering and custom input processing, which allows you to do really powerful things and build some really great fluid experiences. Resiliency for performance is a really fantastic feature to build in, because that's how we can get all of our apps to run really well on low-end devices. A few resources. There are some other sessions I recommend you check out. A bunch of these ones have actually already happened. A few about XAML and XAML performance, games, building UI, and Silvana's talk on direct composition for the desktop is pretty interesting, and XAML is built on top of direct composition, especially in Windows 8.1. I think all 5 of those sessions have already actually happened, but if you didn't get to see them, I'd recommend you check out the recordings. Everything I've talked about today is all in XAML applications, so we have this DirectX interrupt APIs in XAML. In the Trident and Internet Explorer side of the stack, we do have OpenGL graphics, so you can check out Frank's talk to hear about that. Most of the code that I've shown today, or didn't show, most of the demos that I showed today are based on some of these samples. The swap chain panel sample, which is brand new, just went up a couple of days ago with the build, and the Surface image source sample has been there since Windows 8, and we're updating that one, but you can use those to see the query interface and all of the other DirectX interrupt to figure out how to get started. There's also an interrupt from Windows 8 that talks about a lot of the same things that I've talked about today in MSDN from Windows 8 also. The Visual Studio team is really excited to hear from DirectX developers, especially about diagnostic tools. They have made some heavily investments in C++ diagnostics and also some in DirectX debugging. So if you would like to talk to them about that and give them your feedback, they would love to hear it. They're in room 254, South Moscone, or you can email them at that address right there. All right, that's what I got.